All right, greetings everyone. This is the first part of the video for section 1.4. Yeah, so we'll jump into that. So section 1.4 is about what are called composition of functions. Okay, so let's look at what that means. So when the output of one function is used as the input of another, we call the entire operation a composition of functions. Okay. And we write f of g of x is how that's read there. So like it says there, that's read as f of g of x, or f composed with g at x. Now, let me explain. So we know normally when you're going to evaluate a function f, so say this function here, at some number you put it on the inside, right? So it would take the place of g of x. So you could do something like, say, f of 7 is what we have done so far. However, in this case, notice that on the inside is not some number, but actually a function and another variable, right? And what does that thing g of x represent? Well, it represents the output of g when we input x into it. So that's where the part in the definition comes out. We use the output of one function as the input of another. So the output we would get from evaluating the function g at x, that would become now our input for f. We would use that then to find the output for that number at f. And I'll do some more concrete examples here in a second. Before that, though, I do want to point out there is some alternate notation I'll use. You'll see sometimes instead of like this, it'll be something like this. So f with that kind of like open dot g of x. So these two things here mean the same thing. And notice in the top one, g of x is the inside function, and on the bottom one here, g is the thing most to the right. So in this case, to the right means inside. Now another thing about composition of functions is here these examples are only using two functions. You can actually do it with as many functions as you want. So I could have something like f of g of h of k of l of m of n of x, something like that. And let's see how many parentheses do I do. So look something like that. Or using that second notation, we could write that as something of f of g of h of k of l of m of n of x. It could also be written that way. All right. Okay, so let's look at how this works with functions. And again, keeping in mind that it's when we use the output of one function as the input of the next one, or of many next ones. So let's look at an example using tables. Okay, so over here on the left, notice we have tables for two different functions. The top one here, this is for the function f. The bottom one is for the function g. And in these, the top rows, those are inputs. The bottom rows are the corresponding outputs. Okay. So we're going to use these to evaluate these things over here on the right. So first of all, we'll start with g of f of 7. And as I kind of alluded to before, to do this, we want to start on the inside. We're going to start with the f of 7 here. So to figure that out, we go over to our table for f, or for f, sorry. Notice that for an input of 7, we get an output of 6. So now that can take the place of the f of 7, and it's very important that when we're doing this, we write this out how I'm about to do it. So now instead of writing g of f of 7, right, this is g of what f of 7 is, which is 6. So we've taken that output from f, it's now become the input for g, and now we must find g of 6. So we go to the bottom table. Again, we're now using that 6 as an input for g, so we're using this input here, and we see the output is 10. So g of 6 is 10, so what we really see is that g of f of 7 is 10. Okay? And we do a similar thing with these other ones. So Again, start on the inside here, g of f of 5. We look at for f of 5. That comes from here. Looks like if we input 5, we get an output of 2. So this will become g of now 2. And then we look at the table again for g. There's an input of 2 gives us an output of 3. Okay, so we see that g of f of 5 is 3. For the third one, we do in the opposite order now. So now we actually have g on the inside. So we have f of g of 2. So if we start by finding g of 2, which as we just saw is going to be 3. So this will now become f of 3. So now that means we input 3 into the function f, and it looks like when we do that, we get an output of 7. Okay, so f of g of 2 is 7. Now, another interesting thing about composition of functions is you can actually compose a function with itself. So notice on this last one, we're asked to find f of 3, which might look kind of crazy, but we can still do the same process we did before. So start on the inside, find f of 3. You see that that's 7, so this would actually become f of 7 now, which means we input 7 into our function f, and we get 6 as an output. So f of 3 gives us 6. Cool. All right, and that's using doing function compositions using tables. All right, let's look at function composition using graphs then. So here we have two graphs of two different functions. We've got k of x, whoops, not that. We have k of x over here on the left, m of x over here on the right. And notice that even though we're using graphs, we can still do these the same way. So if we're going to do, say, m of k of 1, well, just like on the last one, we're going to start on the inside, so find k of 1. So to find k of 1, we go to the graph for k, which is one left. Look for the point where input of 1 intersects with the graph, which is there that I circled, so it looks like that gives us 2. So then we'll have m of, and in place of k of 1, we're going to put a 2. To find m of 2, we go over to the second graph for m, look for the points, the output we get when we input 2, and it looks like that is -1. Okay. Let's do a similar thing with the next one. So k of 2, or so we're finding m of k of 2, but we'll start on the inside, k of 2, which in this case is going to be this point here, and be careful that input of 2 there, well, it's right on the horizontal axis, so that means that we don't move up or down to get the output, so this will actually become m of 0. Okay, and then m of 0 means go over to the second graph for m, 0 is right at the origin, and the output we get is up here, so it looks like we get a 3 there. Okay, so m of k of 2 gives us 3. The next one now, the k of m of 0, now is we're going to switch this around. So first we'll start with the stuff we get for m of 0. So we just saw that's this point up here, so that's going to be a 3. So this will now become k of 3. Okay, and then evaluate the function k at 3. There were 3 on the horizontal axis. Notice it intersects with this point down here, which gives us an output of -2, if I could draw correctly. There we go. All right, and then just like we saw with tables, we can also compose a function with itself. So find k of 2. Start on the inside here, find k of 2, which gives us this point here, which if we see that for an input of 2, we get an output of 0, so this will become k of 0. Input of 0 gives us an output up here of 4. We see that k of 2 is 4. All right. Great. That's all for now. Thank you for watching.